Let's see. Okay. I'm going to see if this is coming up. Let's take a look. It is coming up. Perfect. Okay. Let's see if this is coming up. Let's take a look. Okay. Here we go. All right. Hello everyone. I hope you're doing great. Happy Sunday. Thank you for seeing me today as well as in school this coming week. We are on our countdown to the EOC, but don't worry, you will be great. All you need to do is take some time every single day. Remember my story about Jerry Seinfeld. He wrote a joke a day and that was his goal. So every day you're taking 10, 15 minutes, maybe if you stay after school, an hour and a half to just really truly be exceptional. Let me just type this in. Feel free to put your name in. You can if you want. If you don't want, that's totally fine too. Yesterday's video, I already talked about how to do transformations. Today, we're going to be focusing on specifically constructions. So again, reminder, growth mindset. I'm seeing people sign in. That's fantastic. Love it. You got to take action. If we're going to be successful, we have to take action. I intentionally left my door open in the back. That is the closet that I now do my work and write in, but I figured you deserved a little bit more space than that. And let's figure I got Ginger. So, but anyway, that is my space that I can sit separate and work. So I had you reflect, where is a place that you need to work? And that is the place that you should be. We are going to be specifically looking at constructions. This is going to be really quick. I'm hoping less than a half an hour. That's kind of the goal. You do need, as I have up here, paper, pen, and pencil. Just don't watch me like I'm on Netflix, please. Try to do some projects. Hopefully you have your EOC notebook and you have these questions already embedded in your notebook so you can make those changes too. All right, let's just zoom through here. We already went over transformations in my previous one. We talked about sliding and we talked about rigid motion, that translations, rotations, and reflections are all examples of rigid motion. They preserve congruence. Dilation, those things getting bigger and smaller are examples of similarity and congruence. And the things that you're going to see it the most frequently will be perhaps if you have all circles are similar. That is when we've used transformations this semester. So there's tons of transformations in the previous semester, but this semester, that's where dilations come into play, that all circles are similar. But today we're going to be talking about construction. So here we're going to go. You're going to open up your notebooks to about this page. So after you have all your transformation stuff, after you have those 10 EOC level questions, you should have these in. You might have been awesome and glued them in yourselves, or awesome in the sense of that you hand wrote it. A couple things to think about. When we look at parallel lines, you're not going to have to draw any constructions, which is the great news. Both tests, there's no possible way you could draw constructions. The first test coming up, the EOC, there is the selected response multiple choice. There's the technology enhanced questions where you might have multiple selections. You do have to write your own response, and there is the extended response, but there's no way that you can show that you can draw construction. So you're not going to have to worry about how to use a compass, but you are going to have to know the steps because they could ask you, like, what would the next step be? So if we look here for constructing parallel lines, the main thing is first you have your point. So it wants you to construct a parallel line through point P. Almost always they're going to give you a straight line to begin with, and they're going to give you point P. The first thing is you're going to draw any line that goes through P. It doesn't matter. So if this is it here, I might draw, here's my P. I could draw a line that went like this. I could even draw a line that went like this. It doesn't matter. All you're doing first is you're drawing a line. Then after you do that, it says your next step is to copy the angle. And hopefully you kind of remember doing that before. And basically the idea is that you're doing the arc. So first you're going to put your, you would put your compass there, you would draw the arc, and then you'd measure this distance, come back up here, draw your other arc. and then you're going to extend the line for your new angle. Now, I'm not going to spend a whole lot of time really truly going through this because, again, you don't have to know how to do it like each step by step to actually use the compass. All you need to know are the steps. So you need to know, okay, step 1 is I draw a line connecting P to the line. Step 2 for parallel lines is I construct angles. Step 3 is to draw that straight line coming right through. Hey, Favor, good to see you. And good to see everyone else who signed on because I know there's other kids that are there. The next thing for constructing line segments, first, it wants you to draw your line segment. So see how it says construct the line segment that's congruent to AB. So you're going to use the straight edge of your compass because our compasses are one of those cool ones that we have straight edges embedded. And you're going to kind of like measure the arcs and move on. So really, I don't want to take a whole lot of time talking about these steps because you either know them or you don't know them. Let's take a look at the next set of stuff. Let's trash this and go to the next page. Congruent angles. You're probably going to need to know congruent angles. This is important for congruent angles, and we go back up to the parallel line. So if you didn't know how to do an angle for parallel lines, you're going to want to make sure you know the steps for congruent angles. Here it tells you again, you're going to put your point there. You're going to make an arc. And then you're going to measure that distance. Let me go to my pen tool. Hold on. You're going to measure that distance, and that's where you kind of do it. And then you connect the points using that same opening. Angle bisector. I have seen several EOC questions that deal with angle bisector. So if you're looking at this, oh my gosh, there's like 8 or 9 constructions that Miss Eric wants me to memorize. Like this would be one construction that I would truly know more about. Angle bisector and perpendicular bisector, I've seen EOC questions about. So these would be the biggest ones. Here it tells you draw the arc, and it just takes you through the steps. I don't want to waste time going through it, but you really should, especially angle bisector, pay attention to on this set of questions. Okay, let's go down to the next grouping. As I mentioned, the other one that's going to come up a lot is perpendicular bisector for some reason. Not only is it the perpendicular bisector, but it's helping you to know, hi Cordelia, helping you to know what a perpendicular bisector does. So angle bisector clearly divides the angles in half to have equal measures. Like whenever you cut it, you split it. Similar to that unit 1 question that we did with hexagons, where we had to like draw those different lines of symmetry that created the different angles. Now for perpendicular bisector, not only are you bisecting the line, and bisecting means I've got your names down who've signed up. Thank you. Not only do you have those lines put up that separates it and bisects it into equal points. So like we know that this side right here is equal to this side right here. The other thing that we know is that it creates a right angle. So those are qualities of perpendicular bisectors that you're going to have to remember. I have seen, so this is another big one. Remember I told you angle bisector, perpendicular bisectors are very, very important ones. Here it talks about, again, constructing an inscribed circle. Now, if you know the fundamentals, like you know how to copy an angle, you know how to do angle bisector. Thank you. I see you, Bryce and Aaron. I'll write your names down in a second. Welcome. Basically what you're going to do is to construct the inscribed square, you're going to do the diameter first. And I have seen an EOC question that references this. And then you're going to do the perpendicular bisector of the diameter. And the reason why you do that is that's going to help you find the center of your circle. And then you'll be able to do a 90-degree angle. And we know that 4 90-degree angles equals 360 degrees. And that's how we could then connect our dots for the inscribed square. I don't know how often you guys are going to see that. Excellent, guys. I got your names written down. Welcome, welcome, welcome. Okay, let me trash and let's go on to the next one because I really want most of our time to be spent on the questions. Welcome, Jason. I got you too, sweetie. Excellent. Next, doing the hexagon. I don't know if you're going to really see this. Pretty much what I want you to get from these 2 slides is if you can do the hexagon, you can do the triangle because all you're going to be doing is connecting every other point. So here, when they did their hexagon, again, it's going to be really on you to learn the steps because I can't in a quick 20-minute, half-hour video teach it to you. So you'll just have to know it. I don't know how frequently you're going to see hexagon. I could be wrong. You could tell me, Miss Erig, I didn't study hexagon and there was a hexagon question on the EOC. That's possible. The good news is there won't be a constructing an inscribed hexagon question on your final because this is a unit 1 topic and your final district assessment only covers starting at circles, unit 4s, 5, and 6. But anyway, if you got the hexagon, all they want you to do for the equilateral triangle is just to connect every other point. So basically the triangle is like embedded inside the hexagon, which is inside the circle. So that I think is all of the transformations, but I really want us to go ahead and look at these questions. I do have a Kahoot, but I'm thinking, I don't know if we should want to play. Do you guys want to be brave and play the Kahoot? Let's see. I might be able to pull it up. Let's see. It's loading. I don't remember if I'm logged in on this computer for you guys to do it. I'm not. Let's see. Okay. My Kahoot's good. One person wants to be brave. Let's see if we can play Kahoot. Construction review, play, 7 questions. Oh, that's true. If you're watching it on your phones, you might not be able to play. All right. I'm going to just go ahead and still have us go through this. You don't have to worry about signing up. Okay. But let's at least look at the different questions to make sure that we have it. Let's see. That's not even going to let me do it. All right. There is a way that I can preview it. Let me see if I can go through the preview. And then that way I can pause and let you type out your answer. So it won't be able to be erased, but at least we'll be able to go through these questions. Mm-hmm. 8360. Did you say team awesome? All right, this is so loud in my ear. So I'm going to mute this and we're going to get started. Okay, so I will pause until someone types what they think the answer is. So that's how we'll go ahead and do it. So which illustration shows the correct construction of an angle bisector? So hopefully it'll populate soon and you can tell me what you think and then we'll click and see if we're right. So basically looking which one of these is the proper construction of an angle bisector. Has it come up yet? It has. Anyone got any ideas? Red, blue, yellow, green? It was yellow. I guess the delay is too much that we're not going to be able to do it. Let's see. I will just, I guess, give the answer so you can still look at it. So I'll wait about 10 seconds before we go ahead. Let's see. Now your stuff came up. Okay, let's look at this one. Which construction is represented by the diagram below? Unfortunately, oh, Ginger's going to start barking because she sees someone's reflection in the window. So copying a line segment, bisecting a line segment, rotating a line segment. I'm sorry. I'm going to mute my mic for a second while she finishes her barks. Okay. That was bisecting a line segment simply because we don't have our perpendicular. Okay. Let's go on to the next one. Let's see. Trash pen. Click next. Now we're going to have the diagram below shows the construction of the bisector of ABC. So now we have a bisector and it wants us to know what else is true. So I've got the measure of angle EBF. So here's EBF. EBF is equal to 1/2 the measure of angle ABC. Oh, so right there, that's the true one. We got that one in time. Boom. Oh, I didn't switch. Boom. It says incorrect. What the heck happened? EBF is equal to the measure of angle ABC. They are wrong. That is not true. They are wrong. This is a bad one. They are wrong because EBF is this one right here, and that's not equal to the measure of this whole angle ABC. So you know what? I guess I'm glad that we're not playing. So let's not waste our time looking at this, because if one's wrong, there might be other ones that were wrong. Okay, so moving on. These are the questions that we really care about anyway, because these are the questions you're going to be doing on the EOC, or I mean, maybe not these exact questions, but these are EOC level questions. So if you have your notebooks, you are going to turn to these questions, which are located after your constructions. So this I will have wait time so we can get answers. So which illustration shows the correct construction of an angle bisector? So go ahead, take a look. I know, I'm so sorry. The good news is at least we're going to do EOC level questions. So basically, if we look here and then we go back to the angle bisector pages, which I am going to actually do to help us out, we know that the markings for angle bisector have these little curly Q X's in the middle. Do you see that? And then the line. So this is the image of angle bisector that we really want to know. Good. So we're going to go back over here and we come and look at our pictures, and we want to make sure not only do we have those arcs exactly, but we have these little curves here and the line. So that would be choice 3. Hold on. Next, actually, let me just go back real quick. Yeah. Okay. Next, our next question asks us, which could have been the first step in creating this construction? Coincidentally, it's also about an angle bisector. So go ahead, let's go back and look. I don't want to move it because that could take it away, but what would we end up doing? Would we first place a compass at point A and draw an arc inside Y? Well, if we were to draw an arc, hold on. If we were to draw an arc from A, the arc would look like this. So clearly we know it's not going to be choice A. If we were going to do it from place the compass on point B, again, that arc would have it go here. That looks good. I see that one. Okay. And again, that doesn't match the picture. So that doesn't make sense. We'll cross out B. Favor says C. Let's take a look. Place the compass point on vertex Y and draw an arc that intersects Y and X. Well, let's see. If we put it here and we drew an arc, and we drew an arc from there, that makes sense. That actually matches up. So it is choice C, but let's look at why it's not choice D. Place the compass on vertex Y and draw an arc that intersects point C. Well, if we were to do that, our arc would end up being, look, this whole thing. And that's not on the diagram. So again, if you are not a master at constructions, at least try to do process of elimination and cross out the ones that don't make any sense. So good job, team. Woo! All right, let's go to the next one. Now we're looking at question number 3 in your books. Construction question number 3. Consider the beginning of a construction of a square. Oh, there is a square. There we go. Inscribed in the circle. Step 1 is label point R. On Q, draw a diameter. Label the point where the diameter intersects as T. What's the next step? We just did this. Remember, we did this when we looked over it. So draw radius SQ. Well, the thing is, this could be a radius SQ. So we know that that's not perpendicular bisect, or I just gave you the answer, sugar shoots. In order to construct a square, we need to construct the perpendicular bisector because we need to create those 90-degree angles that I talked to you about when I drew the circle like this and we shared it. Yep, that's exactly right. So it's not going to be S because we have no way of knowing that this angle is 90 degrees just by drawing a radius. So it can't be choice A. Label point S on Q. Again, us just picking, we could have S here. We could have S over here. Neither one of these help us in determining, is it perpendicular for sure? So it can't be that one. Construct a line segment parallel to RT. Well, if we did that, it would look like this ish. And that's not going to help us draw a square. So just by process of elimination, we know it's going to be choice D. The main thing to remember is construction of a square. Well, these are right angles here. A construction of a square also gives us the right angles here. Now, the real reason has to do with like the diameter of the circle. And we know that this is 180 degrees. And we've talked about before that whenever you have an intercept or an inscribed angle, that the intercepted arc is 180 degrees, the diameter, you know you form 90-degree angles. So that's why you need a perpendicular bisector. You need one diameter here and one diameter here with those 90-degree angles, because that'll make these opposing arcs 90 degrees. My picture looks really ridiculous, but that's why you do it. Because remember, construction of a square, squares have right angles, perpendicular bisectors have or form right angles. That's like the only thing I can think of to remember that type of thing. All right, let's take a look at this. Back in your books, looking at question 4. A student is working on a geometric construction. If AD is drawn, what geometric construction is shown? Ooh, let's take a look. Well, there's no way you really can measure an angle with a construction that I know of. I could be completely wrong, but I can't think of a way to do it. So we're going to cross that out. Perpendicular bisectors, remember, looked like this. And so that clearly doesn't look like a perpendicular bisector. I'm going in reverse order on purpose. Copying an angle, basically, remember, that's going to be something like this. And then we have our other angle somewhere else, which again, that doesn't look like two angles. That's only one angle. So by process of elimination, it's got to be the angle bisector. Now, hopefully you remember that the reason why it's the angle bisector is because this is what an angle bisector looks like. And again, for the angle bisector, all you do is you put your point down, you draw this little arc. Ta-da! Then from this point, you're going to draw another arc, and that's how you get this part. And then where they intersect, that's how you get that one. And then you draw your line. So it's hard to show you without a compass. But again, really, truly, if you just take a couple seconds, not feel overwhelmed or rushed, you, by process of elimination, should be able to get a lot of these with just a basic understanding. All right, going on to question 5. You guys are doing fantastic. Based on the construction below, which statement must be true? And this is the one that we got wrong on the Kahoot. Okay, let's just look at it. If ABD, so let's draw ABD. Here's our ABD. That equals 1/2 of CBD. Well, we know that this is an angle bisector. That's really large. Let me go smaller. So because it's an angle bisector, we know that this angle and this angle are the same. So there's no way that that angle and that angle are half of each other, simply because it's an angle bisector. These angles are the same. So it's not that. Angle ABD, I'm going to just do that instead. Angle ABD, so here's our ABD, equals CBD. Ta-da! That's our answer. That's exactly what an angle bisector does. So it's choice 2. Just make sure that we're correct. If ABD, the measure of ABD is equal to the measure of angle ABC. Well, very clearly, I hope you notice that there's no way that that blue angle is the same size as the pink angle. So it can't be that one. And lastly, angle CBD is equal to 1/2 of this angle. Well, that would be about what 1/2 of that angle looks like. So if I color it in, it's very clearly that this yellow angle does not equal the same as that little yellow angle. So that's why it's it. Again, don't just be like, I don't remember constructions, I'm going to skip it. Try what you can do and then just move on. You guys are doing great. We got 3 questions left. Okay, which diagram shows the construction of a perpendicular bisector? Ooh, good one. Okay, this is the same thing that we've done before. I almost want to make you go back and look. Why don't you go back and look? Let's go all the way up here because this is one that kids often get confused. Whenever you have the perpendicular bisector, you're going to have things on top and bottom because that's how you know you're going to draw a straight line. You have to have a beginning point and an end point to draw your straight line. So given that, let's scooch ourselves back down here. And then the only one that has something on the top and bottom is this one. The reason why it's not this one is you need to have it so the points intersect so you know where to draw and connect your line. Here, there's no little hash marks. There's just a curve from a random line. And then this doesn't have a bottom section. So that's why it's got to be choice number 1. Okay, we're almost done. 2 questions. Awesome, mathies. Which geometric principle is used to justify this construction below? I will tell you, I screwed up on this one. This is actually from, I think, Unit 2 on similarity, congruence, and proofs. It's even though it says construction. The main thing is, what do you see with these angles? So if I color this in, and even it's mostly to justify these angles, but you're going to look here and think, okay, what type of angles are these? Well, whenever you see parallel lines, you've learned about vertical angles. You've learned about alternate interior, alternate exterior. And you've learned about corresponding. Okay, those are the main things that you've learned about. A line perpendicular, there's nothing there that's perpendicular, so let's cross out and eliminate choice 1. 2 lines are perpendicular if they intersect. Again, nothing there about perpendicular, cross out choice 3 or 2. Which 2 lines, when 2 lines are intersected? Do you see how, do you see highlighter tool, how this part right here, let's make it bigger, and this part right here are the same? Because they're the same, I recommend just crossing it out. Like, I know you technically can't cross it out on the district assessment. This wouldn't be on the district assessment anyway, because it's Unit 1. But nonetheless, because don't just reread it. It makes it more confusing. So now if we neglect looking at the yellow, we can just read the other parts. The other parts say alternate interior angles and corresponding angles. So now all I'm really looking at, which is it? Is it alternate interior? Or is it corresponding? So you do have to know that they're corresponding angles. If it was alternate interior, the angles would be this one here and this one here. That would be alternate interior. But the main idea is like, do you see perpendicular? Do you see right angles? No, you could eliminate 2 answers right there. Then cross out the repeated information. So that way, all you do is look at the single words that matter. Our word that matters here is alternate interior, and here it's corresponding, because everything else is exactly the same. And that's the only thing that's different. So sometimes when things are just super, super wordy, just go ahead and look for what's different. That's all you need to do. Last question, right? Yep. Based on the construction below, which conclusion is not always true? So AB is perpendicular to CD. Well, we know, hopefully remember, that this is a perpendicular bisector. I told you that that's one of the things that's really important, and it forms right angles. So right away, we know that it's a perpendicular bisector. So of course it's going to be, that's very thick. Of course it's going to be perpendicular. AB, here we go, this measure here is equal to this measure here. Well, there's really no way of proving that, and that's not always the case. So this actually is the correct answer, but let's go ahead and make sure that the other ones we've proven. AE, this line here, is equal to EB. Well, we know that's the truth simply because it's a perpendicular bisector. That's the whole point of what it does. It bisects the line. CE is equal to DE, which again, we also know that's a truth. That's part of what it means for the perpendicular bisector. So that is the answer. It's choice 2. All right, lovies, that is all I have for us tonight. I am going to close with kind of what I started with real quick. If you can see behind me, I have that room with the black chair in it. That is actually my office space that I talk to most of you about, where I do my writing. And the reason why I wanted to have it up instead of having the door closed is hopefully wherever you are right now, you're in a place that you're really focused and studying and not distracted. And I'm just asking you to commit for your own benefit and your own self for the next 10 days to find your, in essence, closet. This is my little closet office. Wherever that space is that you can focus and be your best, that's the kind of space that you need to really study. Then I'll let you take a week off from studying, but we're going to go back in to do really great on the final. I'm going to leave it right there. You guys have been awesome. I will see you later. Thank you so much for participating. If you want to subscribe, I saw someone did. That's great. Otherwise, I'll see you in class. All right. Bye, guys. Ciao.